So in this lesson, we're going to try to solve story opportunities, which is my positive spin on word problems. They're not word problems, they are story opportunities. Okay. So we're going to use the Pythagorean Theorem to be solving these things. And we're going to begin our exploration of exponents. So we're going to start talking about exponents today and rules of exponents, reviewing those things. All right, so the Pythagorean Theorem states that for every right triangle that's got a right angle in here, meaning two of its legs are perpendicular, the sum of the squares of the legs equals the square of the hypotenuse. Right? So the legs are the two sides that form the right angle, and the hypotenuse is the side that's opposite the right angle. So this side is a leg, this side is a leg, and this side, the side opposite the right angle, is called the hypotenuse. Okay, so in symbols, if you label the two legs A and B and the hypotenuse C, then you write A squared plus B squared equals C squared. So it's important to remember that the hypotenuse is always the thing on the other side. You add the squares of the legs, that equals the square of the hypotenuse. So you got to make sure it's the hypotenuse that's the thing by itself.
So is it always equal?
Yep, whenever you have a right angle, it's always a leg squared plus a leg squared equals the hypotenuse squared. Yeah. Okay, so let's do a quick example where we use the Pythagorean theorem. So you're shopping for a home entertainment center, you find one that's a great price, you want to buy it. The space where the TV would put in where you'd put your TV in the entertainment center is 17 inches by 21 inches. And you're wondering, at home, you have a 27-inch TV. You know that it's 27 inches because you remember when you bought it, it was advertised as a 27-inch TV, right? But the way we measure TVs, when TVs are advertised, they just tell you the length of the diagonal. That's what that 27 inches represents. Okay, so my TV is 27-inch diagonal, and I want to know if it will fit in this space 17 by 21. So draw a little picture. I've got a rectangular space in my entertainment center. It's 17 inches by 21 inches. The diagonal, in order for my TV to fit in there, the diagonal has to be at least what? 27 inches, right? So let's figure out what this diagonal is. We could call it, give me a letter. B, F. How about D for diagonal? Okay, so how could I figure out what that length is? Yeah, so my right angle, because rectangles have right angles in their corners, right? My right angle is right there. So my two legs are the 17 and the 21, and the hypotenuse is the D. The side across from the right angle is the D. So if I write down my leg squared plus my other leg squared, that's supposed to equal my hypotenuse squared. And then I'm just going to figure out what D is. So I'll pull out a calculator because I can't square 17 in my head. I mean, I could if I wanted to, but I don't really want to. 289. Okay, so 17 squared. 289. So I'm going to replace my 17 squared with a 289 plus 441. 441. That's supposed to equal D squared. All right, so 289 plus 21 squared, 730. Okay, so I have 730 is equal to D squared. So if a number squared is 730, how could I figure out what the number is? Square root, yeah. So think about do, undo, right? From the last math class you took. So I squared D. To undo squaring, to get D by itself, you need to undo the squaring, and to undo squaring, you take a square root. So I would take the square root of both sides, and we get D is approximately the square root of 730. is a little bit bigger than 27. Let's say 27.02, right? So will my TV fit in there?
Yes.
Yes, because the TV diagonal is 27 inches. It will just barely fit, right? Yes, the TV fits. Questions there? Yes.
Can you just like square 27? See those two numbers added together. Square.
You could. What if it didn't equal it? Does it automatically not fit? No, it might be smaller, right? Yeah. So that would also be a good approach. Yeah. As long as you don't automatically say no if it doesn't equal, right? Could still fit. It could be smaller than the space. Yep. All right, let's shift gears for a minute here away from the Pythagorean theorem. The Pythagorean theorem has squares in it, right? Squaring things. So we're just going to use this as an opportunity to talk about exponents in general. Many of the rules for working with exponents follow naturally from the definition of an exponent, which I'm sure you have seen at some point before, right? So exponents mean repeated multiplication, right? So 7 squared means multiply 7 times 7, and you get 49. 5 to the 4th means you're going to multiply 5 times itself 4 times. So you write 5 times 5 times 5 times 5. We've got 4 of these, right? And 5 times 5 times 5 times 5 is 625. And 2 to the 8th, that means you're going to write 2 times 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 2, 8 times, right? And that comes out to 256. So it's just the definition of an exponent. Means whatever the exponent is, you multiply the base times itself that many times. All right, so the 5 laws of exponents, many people just memorize these properties, but they follow very naturally from the definition. So if you ever forget what the rule is, you can remind yourself by just using the definition of an exponent. So let's think about if I wanted to do 3 to the 5th times 3 squared. What does 3 to the 5th mean? 5 times, yeah. So I've got 3 times 3 times 3 times 3 times 3. That's 3 to the 5th, right? What's 3 squared mean? 3 times 3. Okay, so I've multiplied how many 3's together total? 7. So I could write that's 3 times 3 times 3 times 3 times 3 times 3 times 3, right? Because those parentheses don't matter. It's all just multiplication. So how could I write that using an exponent? 3 to the 7th. So what shortcut could I have used when I was multiplying 3 to the 5th times 3 squared and gotten 3 to the 7th? You could have added the exponents. So that's the standard rule. When you have like bases, you can add if you're multiplying like bases, you can just add the exponents. So that's what this rule on the left says. Like bases, multiplying, you can add the exponents. But if you ever forget that rule, you can always just write it out, right? Like we just did. Takes 2 seconds. All right, what if I want to do 3 to the 5th over 3 squared? 3 to the 5th means 3 times 3 times 3 times 3 times 3. 3 squared means 3 times 3.
You just cancel out those 3.
Yep, and then you can cancel this 3 and this 3 and this 3 and this 3. It's all multiplication, which means you can cancel. And so how many 3's do I have left? Yeah, I have 3 3's in the top of the fraction, 3 to the 3. So how could I have more quickly done this problem? Little shortcut. Subtraction. 5 minus 2 would give you the 3. So that's my general rule. If you're dividing like bases, you can subtract the exponents. All right, what if you raise a power to a power? If I want to do 3 to the 5th squared. All right, well, what does 3 to the 5th mean?
3 times 5 times.
3 times 3, 5 times, right? What does squaring mean? Do it again, right? So 3 to the 5th squared means 3 to the 5th times 3 to the 5th, right? That's what it means to square something. You multiply it times itself twice. And 3 to the 5th means 3 times 3 times 3 times 3 times 3. Then I have another 3 to the 5th, 3 times 3 times 3 times 3 times 3, right? That's 3 to the 5th. That's a 3 to the 5th. So how many 3's do I have written down total? 3 to the 10. So what could I have done as a shortcut to get from 3 to the 5th squared to 3 to the 10th? Multiplied the 5 times the 2. Yeah. So that's the general rule. When you are raising a power to a power, you can multiply the exponents. But if you ever forget, like it's very common to mix up these two rules and forget which one is which, just write it out, right? Yes. Nope. So there's only one base, the x, right? So what would you... So you could square the 3 and do 9 and then do 9 to the 5th. That also works. Yep. Yep. All right. What if I want to do a multiplication problem? 3 times 4 quantity cubed, right? Well, cubing means multiply that thing times itself 3 times, right? So this means 3 times 4 times 3 times 4 times 3 times 4. I just copied the thing in parentheses. I copied it down 3 times because it's being cubed. And then multiplication can be done in any order, and this is all multiplication. So I've got 3 times 3 times 3 and 4 times 4 times 4. How could I write that 3 times 3 times 3 using an exponent? 3 to the 3rd. 4 times 4 times 4, that is 4 to the 3rd. Right? So the general rule is that people often say distributed is not distributing, but it looks like distributing. Right? If you want to raise a product to a power, you have to raise both pieces to that power. Both factors have to go to that power. So 3 times 4 cubed is 3 cubed times 4 cubed. All right. Same thing with a fraction. 3 over 4 cubed means 3 over 4 times 3 over 4 times 3 over 4. It's just the definition of an exponent. And then how do you multiply fractions?
Sometimes you multiply all your tops.
Multiply all your tops, multiply all your bottoms. 3 times 3 times 3, that's 3 cubed. 4 times 4 times 4, that's 4 cubed. So if you want to raise a fraction to a power, you can raise the top and the bottom to the power separately. Is that okay? So like I said, there's 5 rules. At some point in your mathematical education, you'll have used them so much that they'll just be in your brain forever. But if you ever forget them, it's very easy to remind yourself just using the definition. Okay, so it's important also that we can handle negatives when we're dealing with exponents. So -4 with parentheses around it, squared. But I mean, when you square something, that means take that thing and multiply it times itself twice, right? So -4 squared means -4 times -4. And what is -4 times -4?
16.
Positive 16. Yeah. All right, now alternatively, if you write -4 squared and the negative is not in parentheses, there's an imaginary little 1 there. This actually says -1 times 4 squared. Little imaginary 1 there. -1 times, what is 4 squared? 16. 4 times 4 is 16. -1 times 16 is -16, right? So when the negative is not in parentheses, when it is in parentheses, it goes away, right? Because you do negative times a negative and it becomes positive. When it's not in the parentheses, it actually is standing for multiplying by -1, which makes the answer negative. All right, let's combine the two. I've got a negative in the parentheses and outside of the parentheses.
That's like a little -1 outside the parentheses.
So that's like a little -1 times -4 squared, right? -4 squared, I already know what it is. It's 16. We did it earlier. So this is -1 times 16, which is
16.
-16. All right, so you got to watch for where the parentheses show up when you're dealing with exponents. No, because the order of operations says that you have to do the exponent before the multiplication. So you have to square that -4 first and then multiply by -1. Yeah, that's a good question because we get into the habit of whenever you see two negatives next to each other, you just make them pluses, right? But you got to be careful with the order of operations there. Square before multiplying. All right. In addition to the 5 laws of exponents that we just talked about, there are some other properties of exponents, and one of them that's really important is that when you raise a number to the 0 power, it doesn't really make sense in terms of our definition of exponents, meaning repeated multiplication. Like, how do you write down a times itself 0 times? It doesn't really make sense. So we have decided as a mathematical community that it makes sense that the answer should be 1. And we're going to see the justification, the reason why we chose that to be the answer to something to the 0 power next class. But let's just see if you can use it, right? What would 4 to the 0 be? 1. Anything to the 0 gives you 1, right? What about this crazy mess in parentheses here? 5x to the 4th over y to the 17th, all raised to the 0. What's the answer? 1. How about -3r, all in parentheses, raised to the 0? 1. Okay. How about if it's not all in parentheses? What if it's -3 times r to the 0?
R becomes a negative. Becomes 1, so you're multiplying -3 times 1.
Yes. R to the 0 is a 1, so I replace the r to the 0 with a 1. -3 times 1 is -3. All right. The r to the 0, this guy right here, is a 1. Yeah. 4 to the 0 is 1. Yeah. Anything raised to the 0 is 1. Yeah.
You took that R, if that was a 1 times from -3, same thing.
Yeah. Mm-hmm. Yep. All right, so that's it for the lesson. You can start working on the activities, and I'll be around to discuss them with you.